Now we are looking at chapter number 3, pair of linear equation in two variables of class 10th. So there are various situations which can arise. Before discussing the actual aspect of these equations, let us take a story. Now Akhila went to a fair in her village. Now she wants two things. She wants to enjoy a ride in a giant wheel also, and she wants to play hoopla also. The number of times she played hoopla is half the number of rides she had on the giant wheel. Means if giant wheel is x, number of times she played in hoopla is x by 2. If each ride costs rupees 3, means for giant wheel this is 3, hoopla it will be 4. How do you find out the number of rides she had and how many times she played hoopla provided she spent rupees 20? So this 3 rupees into x plus 4 into x by 2 will be 20. This is the simplest equation we can make. Now we'll see how we can try and make these equation look simpler and solve it. So is it possible to for her to have two rides, one ride, or giant wheel, or no ride? Let us see. We'll solve this query just now. So as I said, if we can denote the ride by x, then of course the hoopla will be x by 2 as I just suggested, because it is half of this. And you know that 3x means 3 times of the wheel to 4 times of this hoopla is equal to 20. Can you find out the solution to this pair? Actually the solution is the solution to the Akhila's problem. So the pair of linear equation in two variable is like this. You have an equation like this. So this is x, this is y. We can make one more equation. We can have various equations. So any equation of this form ax plus by plus c, this is a linear equation. Pair means there has to be two equations. Why? You would ask why we have to have a two equation? Because we have two variables. To solve two variables we have to have two equations. To solve three equations we have to have three equations. To solve or three variables, if there are three variables, we have to have three equations like this. And one more thing, this a cannot be 0 or b cannot be 0. Why? If a and b are 0, then we are only left, if a is 0, we will be left with by plus equal to 0. This is not a linear equation, or it can be a linear equation if you place it 0, but we will not be able to solve it properly. Let us take this equation we just suggested. Place x equal to 1, y equal to 1. If we place x equal to 1 here, y equal to 1, we see that it is equal to 5. Exactly, it is equal to 5. So this is the solution. This is what is the solution, because it is actually satisfying this equation. Right? Now if we put x equal to 1 and x equal to 7, we see that it is actually not solving it, because right hand side is 5. Whether this is equal to 23? No, because 23 and 5 are different. So x equal to 1 and 7 are actually not the solution. So this is not the solution. So what geometrically does it mean? Geometrically it means that if this is a line, 2x plus 3y is equal to 5 is of the form y is equal to mx plus c. If this is a straight line, then 1 lies on this line, while this 1 and 7 does not lie on this line. So any equation ax plus by plus c, if this is the solution, it should lie on this line, otherwise it will not be a solution. Let us take them now formally. These are the pair of linear equation in two variable, one equation, two equation. a1x plus b1y plus c1, a2x plus b2y plus c2. And we have already said that we want this to be intact because we don't want this to be 0. Otherwise it will not be a linear equation, or will not be able to solve for x and y. So these are the pairs of linear equation. These three. Actually these are the pairs. So these are three. Actually there are 6 equations, but the pairs are like this. So there are pairwise 3 equations. So how can we solve it geometrically? We have already seen some sort of things and some discussion in class 9. Two lines can have 3 things. Either these two lines or two equations can intersect, they can be parallel, or these two lines can be similar, means they are equal. Intersection, parallel and coincident. All the discussion in this chapter will actually, take round and go on the periphery of this discussion only. Means it will revolve around these three things. So you should understand it very clearly. So now let us get back to the Akhila's problem. Akhila, y is equal to x by 2. So just take 2 on the left hand side. So 2y is equal to x. So shift this 2y on the right side. This will be x minus 2y equal to 0. Then 3x plus 4y equal to 20. So this already we have seen. These are two equations. Let us solve them. How to solve them? Put some value of x in the first equation, this equation. So you get the y values. So we have placed 0, we get a y value of 0. We place 2, we got the y value of 1. So we are just replacing x so that we can get the value of y. Similarly, for the second equation, we have created it like this, or rearranged like this. Y is equal to 20 minus 3x by 4. So let us place x equal to 0, 20 by 3 and 4. These are just random values, you can take any values. So some value has come. So we have actually got the coordinates. These are the Cartesian coordinates actually. Pair of Cartesian coordinate. And let us make these lines. When we make this line, the whole discussion is about that they are intersecting. And they are intersecting at 4, 2. And this is the solution. This is the solution we are going to get after geometrically representing it. And all the points which we have got, these, they are intersection on the x or y axis. But we are interested in how these two interact, how these two intersect. Let us take one more problem. Romila went to stationery shop and purchased 2 pencils and 3 erasers for ₹9. Let us take pencil as x, eraser as y. So 2x plus 3y is equal to 9. Similarly, for the second friend, Sonali, she also went. She took 4x, 4 pencils, 6y. That is 6 erasers, and it went to 18. We just added. And before going ahead, let me tell you that if I multiply this equation by 2, it will become what? 4x plus 6y is equal to 9 to the 18. These two equations are exactly similar. So they are eventually the same line. So we'll solve it, but you must remember what I'm trying to say here. So similarly, just take y here on everything on the right hand side. So place 0, 4.5. These values are being placed just to get some concrete integral value, so that we can easily place it on the this x and y axis. Again, 0 and 3 we placed on the second axis, we get 3 and 1. Now let us make a line. You see that these two lines are exactly similar. So they can be infinitely many solutions, because for a line, all these points are the solution. Let us take one more case. Two rails are represented by this and this. So these are two rails, and the rails are always parallel, they don't intersect. How they are parallel? Because if you are aware of the slope, that is m, both the equation have the slope similar. But we'll try to solve it the way we are solving it. We'll take some value of x, place it in this, try to find out the y. We placed x equal to 0 here, 4 here. Then we try to find out the y. So we have got the coordinate 1, 2. We are going to place it on the xy axis. Again, for the second number line, or you can say second line also, we'll place x0, 6 here, so that we can get y. Now we have got the coordinates of the 2 points for both the lines. We can draw the line, and we see that these two lines are exactly similar. Means not similar, but exactly parallel. Now these are parallel because they are having the same slope. Now, are they going to intersect at all? No, rails never intersect. So this example has no solution whatsoever. Why? Because they are not going to intersect. You will not get any intersection. So the graphical method of solution of pair of linear equation is very similar to what we have discussed. You just have to take two lines, make them intersect. If they don't intersect, they might be parallel. That means there is no solution. if they don't intersect or they are not parallel, that means they are similar lines, that is infinitely many solutions. These are the aspects which we have discussed just now. So what we are going to call them? Let us summarize. If lines intersect at a single point, we call that these two pair of lines are consistent pair of equations. If lines are parallel, we call, because we are aware that they are not going to provide us any solution, so these are inconsistent pair of equations. And how about coincident? Because those lines are, or these two lines are similar, these are dependent or consistent pair of equations. So these lines intersect, these lines coincide, these lines are parallel. So how to get this in one glimpse? How to get this idea in one glimpse? Is there any way? Yes, we do have. If these are equations, take A1, this is A1, B1, C1, this is A2, B2, C2, like this. Oh, sorry. If this is the equation, A1, B1, C1, A2, B2, C2 will be this. Now, just take this table. A1 by B1, we have taken these three equations, A1 by A2, B1 by B2, C1 by C2. We see here that A1 by A2 is not equal to B1 by B2. This is not equal. So this is intersecting line, we have exactly one solution. These two lines, A1 by A2, B1 by B2, these are equal. And they are also equal to C1 by C2. So these are coincident line. There is only one single line, so they are providing us infinitely many solutions. These two equations, A1 by A2 and B1 by B2, are similar. They are equal, but they are not equal to C1 by C2. In this case arise, we say they are parallel lines, and we are not going to get any solution. So this is what we summarize. A1 by 8, if these two are lines, A1x plus B1y plus C1, A2x plus B2y plus C2, then A1 by A2 is not equal to B1 by B2, they are intersecting. A1 by A2, B1 by B2 are equal, and C1 by C2 is equal ratio, they are coincident. A1 by A2 and B1 by B1 by B2 is equal, but they are not equal to C1 by C2, they are parallel. Let us take the example. X plus 2y is equal to 6, 2x minus 3y equal to 12. For making any line, we just want 2 points. So we are providing some values of x so that we can get value of y similarly here. So we have got the point, let us make them. And we see that they intersect at 6, 0, and 6, 0 is our solution. So these pair of equations are consistent. How about this equation? These are two equations. To make somewhat easier, this second equation, we can multiply it by 5 by 3. So you can get this 5x minus 8y plus 1. And we see these two lines are exactly similar. When they are similar, that means we have infinitely many solutions because they both are same. How about one more equation of Champa? Champa went to a sale to purchase some pants and skirt, x and y, right? So when her friend asked her how many of each she had bought, she answered, the number of skirt is 2 less than twice the number of pant purchased. So 2x minus 2 means 2 less than of 2x is y, means skirt. Also the number of skirt is 4 less than the 4 times the number of pant purchased. So 4 times the pant purchase less than 4 is the skirt. So these two equations she actually Champa posed in front of her friend. How to solve this? These two are equation, let us make it. And when we see that these two, you by now you know that we are just placing points x so that we can get two points so that we can make the line. So these are two lines, they intersect at 1, 0, and 1, 0 is the solution. So exactly, see, 1, 0 is solution means the number of pants she purchased is 1 and she didn't even buy a skirt. Then algebraic method of solving pair of linear equation. Somewhat difficult is graphical. Why? Because if you want to place these points on a number line or on a say xy axis, it will be very difficult for us. So there are some chances of making mistakes. So we have some different methods also. First is our substitution method in algebraic method. How we are going to substitute? Let us take an example. 7x minus 15y equal to 2, x plus 2y equal to 3. Let us take this equation. X plus 2y equal to 3, place 2y on the right side. So x will be equal to 3 minus 2y. Now place this x here in the first equation. So we are placing the x here, which was 3 minus 2y. Solve it. Y equal to 19 by 29. And as we have seen, that x was 3 minus 2y. We have found the value of y. Just place it here. It will be 49 by 29. So x and y is received by substitution method. So substitution is what? Just make one equation in terms of x in terms of y. Place this x in the second equation or first equation and find out the value of y. And once you got this value, then you can easily get by any equation, means two equations which we actually made earlier, you can get the actual equation. If you did not get it, let us try to solve it in a different terms. See, question 1 of 3.1 exercise. What it says, Aftab and daughter, they are suggesting about their ages. If S is the age of Aftab, T is the age of Aftab's daughter. So what is this? If the age of daughter 7 years ago is 7 times the age of Aftab, and after 3 years the age of the thrice of age of daughter will be the age of the Aftab. So this is what we can make easily. And now let us solve it. So s minus 3t equal to 6. So just make 3t or transfer 3t here. So s you get as 3t plus 6. This 3t plus 6, place it here in place of this s here. So solve it, you get t equal to 14. Now you can place it in this also, this also. So this is seen quite simpler. So let us place it here. So the age of Aftab and daughter is 42 and 12. Again, one more example is about the previous discussion. 2 pencil, 3 eraser, 9. So 2x plus 3y equal to 9. And 4 pencils, 6 eraser equal to 18. So 4x plus 6y equal to 18. Now we have seen already that these two equations are exactly similar. If I multiply this equation by 2, these are similar. But let us solve it by substitution. So we will take this one and place it here, 9 minus 3y, and divide by 2. So x is and 9 minus 3y by 2. Place it here in the second equation. So you get 18 equal to 18. So this statement is true. That means it will have infinite many solution, because they both are similar line. So if this kind of equation comes, that is left hand side equal to right hand side, we say it has infinitely many solution. One more example we are going to take. These are two equations. Let us solve it by substitution. X, all y comes here. So 4 minus 2y, place 4 minus 2y in place of x here. Solve it, we get minus 4 equal to 0. So this is wrong. It is not similar to what we got 18 equal to 18 in the earlier example. So when this comes, that means it is a false statement. That means it has no solution. It is just like road. Method, we will try to remove one variable. When we can remove one variable, we can find out the value of the second variable. And when it is used, all the methods being shown here or presented here, you will use the method which is most convenient to you. For example, if the ratio of income of two person is 9 and 7. So if one is 9x, the second is 7x. The expenditure is 4:3. That is 4y, 3y. This is the ratio. Now the saving is 2000 per month of both these guys. So 9x minus 4y equal to 2000 and 7x minus 3y equal to 2000. So this is the equation we are going to make. So what we can do here is we can multiply this equation by 4, this equation by 3. Why I multiplied it? Because both of these values will become 12y and we can easily eliminate it. And this is the process, elimination. So we can just subtract them. This is eliminated. You can find x. You can place x in any of this equation, and then you can get the value of y. You can also verify it. That is 9x, 7x, and x and y you have got. So 4y, 3y, and then you can find out the differences also. That will be 2000. So how you are going to do this? You have to multiply the values, or we'll see one more example. You have to multiply accordingly such that one x or either x or y gets cancelled, or they become numerically equal, so that you can just cancel them out. And then you can find out if x is cancelled, you can find out y. If y is cancelled, you can find out x. And then you can, of course, after finding out the value, the original equation can be used to put the value again, and you can get the answer. So we'll take one more example, 2x plus 3y equal to 8 and 4x plus 6y equal to 7. So it is quite easy because we are aware that if I multiply this equation by 2, this will become 6y and we can eliminate this 6y. So we have multiplied this equation, first equation by 2, and now we can just eliminate it. So this is eliminated and you can see 0 equal to 9, and we know that when this kind of things comes which is actually false, we have no solutions. There are no solutions. Now the sum of two-digit number and the number obtained by reversing the digit is 66. So how to represent the two-digit number first of all? See, if this is 56, how I can write 56? I can write it 50 plus 6. How can I write 50? 5 into 10 plus 6. So if this is x, this is y. This is x into 10 plus y. So 10x plus y. So this is how we represent the two-digit number. How about 10y plus x? Because they are also said reversing. So 56 will become what? 56 will become 65. This is equal to 60 plus 5. That is 6 into 10 plus 5. So this will be y into 10 plus x. So 10y plus x, right? So the addition of these two, the number and the reverse number, is 66. They have told this in the question. So 10x plus y plus 10y plus x equal to 66. So this is the one equation. X plus y equal to 6. X plus y equal to 6. Now the second equation is quite simple. The digit differ by 2. So it can be x minus y equal to 2. It can be y minus x equal to 2. So both possibilities are there. So we'll use both the equations. So now this x plus y equal to 6, x minus y equal to 6, we can just easily solve this because we have y which can be cancelled. So 2x will be equal to what? 2x will be equal to x, this 8. So x will be 4 and y will be 2. And you can also use this with this. We have used these two first, now we'll use these two. So a y minus x equal to 2, and after solving this we get x equal to 2 and y equal to 4. So the number in the first case becomes 42, the second case becomes 24. And you see the difference of both these two are 2 only. Now cross multiplication method. How to solve the cross multiplication method? Sometimes it becomes very difficult to solve the equation by graphical substitution and elimination method. For that we have another solution which is the cross multiplication method. We'll start with an example. We have 5 oranges, say 5x. We have 3 apples, say 3y. So the sum is 35. So 5x plus 3y equal to 35. This is our first equation. Then 2 oranges means 2x plus 4 into apple means y. 2x plus 4y equal to 28. So 2x plus 4y equal to 28. So we'll place it here, means rearrange them. We'll try to find out, rearrange such that right side becomes 0. So these are two equations. Now how to solve them? The best way, we have already seen that, multiply the first equation by 4, second equation by 3. And then we'll have a easy sort of thing because y gets eliminated. So what will be x? X will be this number by this number. So this is your x. And easily when you are aware of x, you can find out the y. So let us formally define it. If these two are equation a1x plus b1y plus c, a2x plus b2y plus c2 equal to 0, x will be this b1 c2 minus b2 c1 by a1 b2 minus a2 b1. See, these, the denominators are same. Y for y, it will be c1 a2 minus c2 a1 by this. So just place the value and you see x and y will be these values. So how to remember this? We'll just see. There is a proper way of learning it also. So these two are equation. What we have done is, we have multiplied this by b2, we have multiplied this by b1, and then we try to eliminate this b. And then when we eliminate it, we place this value which we call just here x in any of this equation or any of these two equations. This equation. So we can place this value in 1 or 2. We can get the value of y. And you see this should not be 0. If this is not equal to 0, then only you get the unique solution. And then if second case, if this is 0, then what you can do? a1 by a2, b1 by b2, because the ratio, because these two are not equal, they are actually equal. So if they are equal, let us make it k. So a1 will be ka2, b1 will be equal to kb2. Let us substitute in our equation 1, and you have already known the equation 1, right? This is our equation 1. We are placing it here. So let us place this in equation number 1. This will be K, then bracket A2X plus B2Y plus C1. And we have observed from the second equation in the 7 that C1 equal to KC2 by this. So C1 by C2 equal to K. So we find that A1 by A2 is equal to B1 by B2, C1 by C2. If we get this, then it will have a infinite many solution. Don't learn or try to just remember these things, because we are going to find out exactly what it means. So the things which I want to summarize here is that if A1 by A2 is not equal to B1 by B2 in these two equations, we get a unique solution. If these ratios are exactly similar, then they are infinitely many solution. If these two are similar but they are not similar to C1 by C2, they are no solution. We have already seen this in the previous discussion. So how you are going to get the solution by elimination method? It will be x by b1 c2 minus b2 c1, y by c1 a2 minus c2 a1, 1 by a1 b2 minus a2 b1. So you have to find out x, just place it here, find out. You have to find out y, just take it here and find out. So what you get here is, see, this is b1. How to remember? For finding x, you have to do b1 c2, you have to write b1 b2 c1 c2 a1 a2 and again b1 b2. For finding x, you have to do b1 c2 minus b2 c1. For finding y, you have to do c1 a2 minus c2 a1, and for in the denominator of 1 will be a1 b2 minus a2 b1. This is how you get it. We'll take an example, then try to solve it. See, you are in Bangalore. Now you can go to Malleshwaram and you can go to Yeshwanthpur. So if you buy 2 tickets to Malleshwaram and 3 tickets to Yeshwanthpur, so 2 to Malleshwaram, 3 to Yeshwanthpur, the cost is 46. So let us assume this is x, this is y. So 2x plus 3y equal to 46. So 2x plus 3y equal to 46. Now if we buy 3 tickets to Malleshwaram and 5 tickets to Yeshwanthpur, so 3x plus 5y is equal to 74. This is our second equation. Just transfer 46 on the left side, transfer 74 on the left side. So we have this equation: a1x1 plus a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. And you know how to solve it. We have just seen. So we place x, y1, try this, right? And then just place it below x, y and 1. So x can be found out by taking this numerator, taking this denominator. Y can be found out by taking this numerator and this denominator. So x and y you have got. Again we have one more example. 4x plus py plus 8 equal to 0, 2x plus 2y plus 2 equal to 0. You have to find out the value of p for which this equation has a unique value. When this will have a unique value, when a1 by a2 will not be equal to b1 by b2. Let us take this is a1, this is b1, this is a2, this is b2. So 4 by 2 is not equal to p by 2, cancel it out, p not equal to 4. So except 4, because p cannot be equal to 4, all other equation or all other pair of equation, you cannot have 4 here. Otherwise all pairs or all values of this pair x and y, this is going to give you a unique solution, only except 4. Now for what value of k, the following pair of equation have infinitely many solutions. You know infinite, a1 by a2 has to be equal to b1 by b2, c1 by c2. This is a1, this is b1, this is c1. a1, a2, b2, c2. Place it here. So you get, by first you get this one, by second you get this one. So by first solving this, k square will be equal to 36, so k can be equal to plus 6 and minus 6. How about solving this two? You get k equal to 0 or 6. So combining this, you take plus 6 as the answer. K is equal to 6. When k is equal to 6, you get infinitely many solutions. Now we have onto those equations which can be reduced to pair of linear equation in two variables. So these are not actually pair of linear equation, but they can be reduced. For example, if you have 2 by x, 3 by y equal to 13, 5 by x minus 4 by y equal to minus 2. This 1 by x you can take it separately. 1 by y you can say take separately. Okay, in this case also. So this 1 by x can be taken as say some p. This can be taken as q. This again p, q. So now you can write it as 2p plus 3q, 5p minus 4q equal to minus 2 and 13. You can easily solve this. You know by now how to solve it. You can use any method. So p equal to 2, q equal to 3. But P was taken as 1 by x, so you have to place 1 by x equal to 2 because P is 1 by x. Q is equal to 1 by 2, 1 by y, that is 3. 3 is 1 by y, so y is equal to 1 by 3. So this is how you get the x and y value. One more example we'll take. We have to solve this equation by reducing them to a pair of linear equations. This 1 by x minus 1 can be taken as P. 1 by y minus 2 can be taken as Q because they are here also. So this 5P plus Q equal to 2. 6P minus 3Q equal to 1. Now these two are linear equations. In two variable, now you can solve. P is equal to 1 by 3, Q equal to 1 by 3. But we have taken 1 by x minus 1 equal to 1 by 3. So you have to solve for x. Now again 1 by y minus 2 equal to 1 by 3, you can solve for y. So x equal to 5, y equal to, x equal to 4, y equal to 5. One more example is that a boat goes 30 km upstream. See, if this is a river and this is flowing like this, so when you are downstream, this river is actually helping you. While you are going upstream, this river is actually not helping you but resisting you, because it is, you are trying to force or go on the other direction. So if the speed of boat in still water is x and the speed of stream is y, so while you go on this side, this will be x plus y because it is going to benefit you. While you go on that side, it is going to resist you, so this will be x minus y. So the speed of boat will be x plus y downstream, x minus y boat upstream. Now you know this equation, time is equal to distance by speed. The question given here is 30 km upstream and 44 km downstream takes 10 hours. So first we'll take 30 and 44. So 30 by x minus y. This is the upstream speed. So let us take time as t1. And 44 downstream, let us take x plus y because it is going downstream. Let us take it as a t2. So t1 plus t2 is given as 10. The addition of the time is given as 10 for these two. So we have taken the first one, we have taken the second one, and we have just added. So these two added is 10. In this similar fashion, the question says that 40 km upstream, 55 km downstream gives you 13 hours, or it takes 13 hours. So this will be 40 by x minus y plus 55 by x plus y. By using time equal to distance by speed, it will be 30. Now here, these two are equations. 1 by x minus y you can take as u, 1 by x plus y you can take as v. So these two equations will become 30u plus 44v equal to 10. 40u plus 55v equal to 13. Take 10 here, take 13 here. Solve that by cross multiplication method. You get u and v like this. Now 1 by x minus y was taken as 1 by 5. 1 by x plus y was taken as 1 by 11. So x minus y equal to 5, x plus y equal to 11. Now these two are again the linear equation of two variables. Now you can easily solve them because you just have to, because you can easily solve by elimination because these two get cancelled out. So 2x will be 16, x will be 8, and y also you can find out. So the speed of boat in still water is 8 km per hour and speed of stream is 3 km per hour. So what we have summarized, what we have learned, let us summarize it. That two linear equations in the same two variables, they are called as pair of linear equation in two variables. And the general form is like this: a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This cannot be 0. If this becomes 0, this will not be a linear equation in two variables. If you want to solve them, there are two methods: graphical and algebraic method. You can use graphical method if line intersect, solution is consistent. If line coincide, you say they are dependent or consistent. Infinite many solution. If the line never intersect, we say they have no solution, so they are inconsistent. When you go to algebraic methods, you can use substitution, elimination, and cross multiplication. So this is how you try to find out whether they are consistent, inconsistent, and dependent and consistent. If these two are equation, a1 by a2 is not equal to b1 by b2, then we say that the pair of linear equations are consistent. If a1 by a2 is equal to b1 by b2, but they are not equal to c1 by c2, these pair of linear equations are inconsistent. If a1 by a2, b1 by b2, and c1 c2 are equal, we say the linear equations are they are dependent and consistent. So there are various ways, applications where this can be used. So this is all about your pair of linear equation in two variable. Thank you so much. Take care of yourself.